You want to control everything with one slider, and it is wrong. In this video, I'll be walking you through how you need to keep some things fixed in Grasshopper so that your definition will read easier. The problem is many Grasshopper definitions become harder when too many things change at once. When everything is reliable, the design can start feeling random. The script still may work, but the logic becomes harder to read. This makes iteration slower and design decisions less clear. What I do instead, I decide early what should stay fixed. I only vary the parts that actually matter. I use fixed elements to give the system structure. This makes the variation easier to understand and easier to control. So I do have an example for this. Let's see, we have the recipe here, we have the recipe here as well. So create one baseline, one base curve, divide it into equal points, keep vertical, create vertical lines at these. So keep the base points fixed, change the only height, vertical lines, compare the results, and so on and so forth. So let's get a curve, set one curve. By the way, if you want to get this Grasshopper file for free, follow the link in description and join my community for completely free, okay? And I divide this curve into, like, let's say 25, okay? And I want to create lines, SDL, on each point with, let's say, it's a Z direction. But you know what we can do? We can create, let's say, Z direction, unit Z, and the length would be the same, okay? And let's say when we want to, if you want to rotate this, oops, my camera is gone, but let me start again. Give me a sec. Okay, I am back. So by the way, plane size is too big, so I'll make it only 1%. And I want to rotate these guys like on XZ plane, XY, not XZ plane at the beginning of each point. So I can take all these points in, or I can create a point. I mean, we're trying to make a messier than intention, but not too messy, of course. Can grab these here, and we can connect this as my radius. So in this case, what this slider does, it creates points, okay, and it basically rotates everything. It's kind of deciding the side of this. What this slider does, okay, what this slider does is basically changes everything, starting from the division and going to the angle and going to the length of these lines. However, what we want to do, we want to keep some things stable, meaning if I am only interested in the angle, what I should do is basically create a panel instead of a slider here. And I need to do, instead of a length, like let's say my length may be 550 here. And then for my only degrees, I can range between 0 and 180. Maybe that's the only angle I want to go with. And obviously I can copy this and paste it here. And I can say, okay, instead of that one, just choose this one. And now these are kind of fixed, okay, fixed values. And this is the value where I change the angle only. Obviously, if you make it 360 max, say okay to this, can have these kind of motions. So the point is, if you want to make changes on some certain things, you want to keep everything in layers. Layers meaning layers of sliders in this case. You want to keep some sliders dynamic, use some panels to fix things. So if I go back to my Google Doc, so what should stay fixed? The baseline, the point, the base of positions, the curve, the overall order of the system. And you saw what happens if you kind of change everything. So this is helpful because design becomes easier to read, and the variation or the only kind of variant that you're changing is easy, very easy to see. The script becomes easier to manage. The output feels more intentional. It feels a lot less random, and it will be easier to communicate this to your colleagues. So not everything. So the main thing is not everything should vary. Fixed part give the system clarity. Variation works better when it has limits, and a good definition needs both stability and change. If you're serious about learning Grasshopper, follow the link in description, book a call with me so that we can sit down and I can help you to elevate your career.